Precalculus, Chapter 2, Section 2. We're going to look at a lot of things with quadratic functions in this section. I may even do these notes in 2 different videos. So let's start with vertex form of a quadratic function. You should remember this from Algebra 2. So the quadratic function f of x equals a times x minus h squared plus k, where a does not equal 0, is in vertex form. The graph of f is a parabola, the U-shaped graph, whose vertex is at the point hk. The parabola is symmetric with respect to the line x equals h. Notice that line of symmetry goes right through the x value of the vertex. If a is greater than 0, the parabola opens up, and if a is less than 0, the parabola opens down. The equation of a parabola in vertex form tells us lots about the graph. So let's talk about how to graph functions of equations in vertex form. So the first thing, step 1, is if it's not in vertex form, you can put it into vertex form by completing the square. Step 2, determine if the graph opens up or down. Then step 3, find the coordinates of the vertex. Step 4, find the coordinates of the y-intercept by plugging in 0 for x. Step 5, find the coordinates of the x-intercept, plug in 0 for y, and sometimes I interchange those steps. It doesn't matter which you find first. Then number 6, graph using those points. And if you need more points to graph, because sometimes you don't have x-intercepts, find those and then graph. I usually like to have 5 points to graph a parabola. Sometimes you can graph it with 3. All right, so let's start with this quadratic function. So it says f of x equals negative x minus 1 squared plus 4. So the first thing we're going to do is look at the equation and determine how the parabola opens. Well, our a value is negative, so it opens down. Then we'll find the vertex, and so that is, we just pick out the h and the k value from the equation. Remember, the h is the opposite sign of what you see. So our h value is actually positive 1, k is 4, so our vertex is at the point 1, 4. Now let's find the y-intercept by plugging in 0 for x. So negative 0 minus 1 squared plus 4. So that gives us negative 1 plus 4, or f of 0 equals 3. So we have the y-intercept 0, 3. Now the x-intercepts we can find by solving for x. So we're plugging in 0 for f of x, setting that equal. So I'm going to subtract my negative 4 over, divide by negative 1. Now I can simply take the square root of both sides. So remember, the square root of 4 is both positive and negative 2. So when I add 1 to those numbers, I get positive 3 and negative 1. So my two x-intercept points are 3, 0 and negative 1, 0. So now we have enough points to graph this. We're just going to remember that the parabola opens down and our x-intercepts, y-intercept, and vertex. I always label my scale, and you should too. And so let's plot these points. So I have my two x-intercepts and my vertex, and now I'm going to plot the point 0, 3. Notice I also plotted the point 2, 3. So when you get your point, in this case, this point, then because parabolas, graphs of quadratics, are symmetric, I can plot the point that's on the other side of the line of symmetry, the same distance away as that first point. And then let's dash in the axis of symmetry just so we can see that parabola. And there we have it, the graph of our quadratic. But what if it's not in vertex form? Okay, get ready. We're going to do quite a few examples where we go from standard to vertex form by completing the square. And so hopefully this process will come back to you. So the first thing that I like to do is to replace the f of x with 0. Sometimes I'll leave it as y. Then we need to move that c value over so that we can create a perfect square. So to complete the square, we're going to take half of the b value, b is negative 8 in this case, and square it. So that gives us the value of negative 4 squared, or 16. Then we're going to add that value to both sides of the equation to keep it equal. We have created a perfect square trinomial on the left side of the equal sign. So now we can factor that. That will factor as x minus 4 squared. Negative 15 plus 16 is 1. Now I can go ahead and subtract the 1 over and write that in this equation in vertex form. So I go ahead and put the y back into the equation and say y equals x minus 4 squared minus 1. Now we can find our vertex. That's positive 4, negative 1. Let's find our y-intercept by plugging in 0 for x. And that will give us the point 0, 15. Now let's find our x-intercepts, if there are any, by plugging in 0 for y. So add the 1 over, take the square root of both sides. Remember, you'll get plus and minus 1 for the square root of 1, and add 4 to both of those. So we have the x-intercepts 5, 0, and 3, 0. All right, let's plot everything we know. We look at the equation, and we notice that the graph opens upward. Make sure that you label your scale. So we're going to plot 4, negative 1, 5, 3, 3, 0, and then my point 0, 15 is off graph, but I just do my best to estimate where that would be. And then let's sketch in the axis of symmetry so we can see how that goes right through the middle of the graph and through the x value of the vertex, and through the entire vertex actually. All right, let's try another one. So let's complete the square to get this into standard form. So in this case, I'm going to replace f of x with y. I'm going to move my c value over and leave space to complete the square. So half of 2 is 1, 1 squared is 1. So I'm going to add 1 to both sides. Now I'm going to factor what's on the left side of the equal sign, and that will factor as x plus 1 squared. And then I have y plus 10 on the right. Now let me pause for a moment. You can see where I wrote the equation, and you can see that where I made a mistake, and I'm going to catch that in a minute because I should have subtracted the 10 over, and instead I left it as positive. So I plug in my 0 to find my y-intercept, and right away I notice that I've made a mistake. Well, pretty soon. There we go. So there I changed this sign, and so now I know that my vertex is actually negative 1, negative 10. So now I can move forward, plug in 0 to find our y-intercept, which is 0, negative 9, then plug in 0 for y and solve. Now sometimes you'll have to estimate your values. So in this case, our x-intercepts are negative 1 plus the square root of 10 and negative 1 minus the square root of 10. So that would be the x values that are approximately 2.2 and negative 4.2. I always round to tenths place. So now let's plot all of those points. This graph's going to open upward and have its vertex at negative 1, negative 10, and so that x-axis symmetry will go right through the vertex at negative 1. Sometimes you'll need to complete the square and it has an a value that is not 1. So what we need to do is we need to factor out the a value. Notice I have moved my c value over, and so I'm going to factor out the 2 here. Now half of my b value is 2, and 2 squared is 4. So I'm going to add 4 to the left side, but notice I'm adding 8 to the right side, because technically what I am adding to the left side is 2 times 4. So now I can factor the expression on the left side of the equal sign, which will factor as x plus 2 quantity squared, and that will equal negative 2. And now I can add my 2 over, so I have this equation in vertex form. My vertex is the point negative 2, 2. Now to find our y-intercept, let's plug in 0 for x. That will give us 10, so our y-intercept is 0, 10. And now let's plug in 0 for y to find our x-intercepts, if there are any. Sometimes there are not. And in this case, there are not, because when we try to take the square root of negative 1, that's an imaginary numbers. And so that means that our parabola is not intersecting the x-axis. So I'm going to graph the points that I know. And so I know the vertex, which is at negative 2, 2, and I know the point 0, 10. And then I use symmetry for this point. And I also know that in a parabola, I have points just by the vertex. And so my a value is 2. So I know that I'll go over 1 and up 2. And I can also just plug in that x value. So if I plug in negative 1 into the equation, I'm going to get 4. And then if I plug in negative 3, I will also get 4. So sometimes you have to find a couple more points to graph your parabola. So now we have negative x squared minus 2x plus 3. So I subtract the 3 over, and then I'm going to factor out my negative 1. So to complete the square, I take half of the b value, which is 1, and square it, and add that to the left side. But what I'm actually adding to the right side is negative 1 here, because it's negative times that positive 1. So on the left, I have negative x plus 1 squared equals negative 4. And then I can add the 4 over and then replace that, put that y back in. So our vertex on this is negative 1, positive 4. Now let's find the y-intercept by plugging in 0 for x. So we'll get negative 1 plus 4, which is 3. So the y-intercept of 0, 3. And now let's plug in 0 for y and find our x-intercepts, if there are any. So we get x plus 1 squared equals 4, and take the square root of both sides. Remember, square root of 4 is plus and minus 2. Subtract 1 from each of those. So our x-intercepts are 1, 0, and negative 3, 0. So let's plot these points. And then I go ahead and add in this point of symmetry here. So I have 5 points, and then I put in my axis of symmetry. All right, this concludes part 1 of the notes for Chapter 2, Section 2, Quadratics, and we'll continue in Part 2.